Hello. Okay, so today we will solve one question that is from NCERT class 12 example first chapter example 1.13. Okay, the question is based on the application of Gauss law. So let us solve this question. Okay, so this is an important question for the board exam and as well as for many entrance examination. So the question is that an early model for an atom, consider it to have a positively charged point nucleus of charge Jd surrounded by a uniform density of negative charge up to a radius r. The atom as a whole is neutral. As you know, atom is neutral. So for this model, what is the electric field at a distance r from the nucleus? Okay, so let me elaborate the question a little bit. So the question is that an atom, this is an early model of atom, so we are considering to calculate the electric field inside an atom and outside an atom. So the early model that you know, before the Bohr model, the one of the atomic model was the center at the center of the your sphere, or you can say atom, nucleus is situated and electrons are uniformly distributed all over the atom. So this was the early model. This was an early model of an atom. Later on, Bohr postulated the theory, and the atoms are revolving in different cells and are present in different orbitals. So we are considering, because we are interested to calculate the electric field for such a case inside and outside outside the atom, okay, at a distance r. So that's why we have chosen this model, but this model is not true now. Now we accept Bohr model, but let us calculate the electric field. So how will you calculate the electric field? As it is at the question suggests that we have the nucleus is at the center. As you know, how many number of protons will be there, or how many positive charge will be there in the nucleus? Jd, Z is the atomic number, and so Jd plus Jd will be the amount of positive charge in the nucleus. What will be the negative charge in this atom? Minus Jd, of course, because atomic number into E will be the this will be the number of, or this will be the amount of negative charge in this atom. Okay, so a negative charge is uniformly distributed all over the atom. Okay, so let us calculate the electric field inside the atom and outside the atom. So for that, and it is given that the radius of this atom is capital R, let us calculate the electric field somewhere inside, let's say at a smaller distance from the nucleus or from the center. So how will you calculate? So what we will do, we will just draw a Gaussian surface. Okay, because you can choose a Gaussian surface according to your situation, according to the situation. So we are drawing a closed Gaussian surface here, okay, with the radius smaller. Now what are the total charge inside this Gaussian surface, can you say? So now let us calculate first the total charge inside this Gaussian surface. Okay, so to do that, let us calculate. So let us first calculate what are the total charge density of this total charge density of the electrons. So let's say the total charge density of electron is rho e, okay, rho electron, and the density of the electron will be, as you know, the charge density is, let's say, delta q by your delta v, volume of the atom. Okay, so what is the total charge? So charge will be delta q is equal to total charge, negative charge. Okay, total negative charge will be equal to, or electrons is equal to your volume into, let's say not write delta only, let's write QE. So V into rho E. So what is the volume? Volume is, as you know, volume of the sphere is 4 by 3 pi r capital Q rho E. Okay, so this is the total charge, total negative charge in this atom, right, in terms of density. Now what will be the total charge? The total charge will inside will be plus JD, that is the number of positive charge, okay, number of positive charge and what will be the number of negative charge? The number of negative charge will be equal to your that is will be equal to that total charge will be equal to rho E into the volume. The volume is 4 by 3 pi r small r cube, okay, density into volume, okay. Or what is rho E? Rho E we can calculate from here, okay. Rho E will be equal to, we can say rho E will be equal to, here we can write, implies that rho E will be equal to 3 by 4 pi capital R Q QE, okay. So Q is the total number of electrons. So now you can write this one plus JD minus what is rho E, that is 3 by 4, QE is what, that is JD, okay, by JD by 4 pi RQ, and this is 4 by 3 pi small rq. So 4 3 pi cancel out, okay. So what will be the total charge inside it? ZE minus JDE RQ by RQ. So this is the total charge inside the Gaussian sphere, this one, small Gaussian sphere, right. Now what is Gauss law? Okay, so Gauss law says that the total flux from Gauss law that is total flux linked with the surface will be equal to Q inside by epsilon naught. What is Q inside? Q inside is this one, that is 1 by epsilon naught ZE minus JD RQ by RQ, okay. Now also from the definition of flux we know that what is flux? We know that flux is equal to E dot, also we know that flux is equal to E dot delta S, okay. That is flux linked with this small surface. So flux linked with this small surface as their direction E dot del S, E magnitude del S magnitude cos theta. So here cos theta will be what? 0. So we will just write E into del S is 4 pi r square. This is surface area. So 4 pi r square, surface area of this Gaussian surface is 4 pi r square. This is suppose equation 2, this is equation 1. Now left side of this equation 1 and 2 are equal. So we can write that right side will be equal. So we can write that E dot 4 pi r square is equal to 1 by 4 epsilon naught JD minus JD RQ by RQ, okay. Or what will be E? Your E, we are supposed to interested to calculate E, okay. So the magnitude of E is inside the atom, E will be equal to, that is 1 by 4 pi epsilon naught, and r square will be divided, will go inside, and also you can take outside JD. This will 1 by r square minus, that is r square will be divided here. So this will RQ by r square RQ. So square Q will cancel. So what will be electric field? So the electric field will be equal to JD by 4 pi epsilon naught 1 by r square minus r by rq. So this is the electric field inside the sphere. What will be the electric field outside the sphere? Now outside the sphere, if r will be outside, suppose somewhere here we are interested to calculate the electric field. Now we will draw a larger Gaussian sphere, okay, Gaussian surface. Now as you can, so this is case 2, when r is greater than capital R, okay, that means outside the atom, that means outside the atom. So outside the atom, what will happen? Now your flux from the Gauss law, that is your flux linked with the surface will be equal to q inside by epsilon naught, q total. So what is total charge? Number of positive charge, number of negative charge equal, so total charge is 0, so q inside is 0, so 0 by epsilon naught, that is 0. Okay, and what is so we can write that from your basic definition of flux, that is equal to E into 4 pi r square, that will be equal to 0, or you can say E will be equal to 0. That means electric field outside the atom is 0. It is also expected because atom as a whole is a neutral. Outside the atom you do not feel any electric field, that's why atom as a whole is a neutral quantity. That's why this result is expected, that E will be 0. Electric field outside the atom must be 0, and we got the same result. And what will be the electric field inside? Electric field inside the atom is ZE by 4 pi epsilon naught 1 upon r square minus r by rq. Okay, so I hope you understood this question. This is a very important question. Let us discuss another question in next video. Thank you.